Niece.
I do have light glare.
How do I unfreeze it?
Oh, yeah. Thanks, Wendy.
I have to worry about my head getting in the way.
Your head doesn't get in the way. It's the kids that get really low that get their head in the way.
Tea? Is that Dutch Bros?
Hannah brought it to me.
That's so nice.
It was nice of her. Wow, look at that. You're all here.
Really?
Mm-hmm.
It was before in. What is it?
Thanks, ma'am. Molly doesn't have trouble fitting in state plan to conclude, Zach. She wrote nice and small for us. All right.
I'm learning.
Michelle's going to plan for us. Excuse me. Thank you, ma'am. Thank you, ma'am. All right, and Amelia is going to conclude for us. Oops, sorry. Made it not straight. Thank you, ma'am. Hannah.
Can you explain like how it's reliability? I'm just confused on.
So it just up in the paragraph, it says that they had them rate the importance of several aspects of bank service. And then it just tells us that we're looking at the summary results for reliability. So that just, it's just, I don't know. I don't know what the other things, friendliness would be an aspect. I'm trying to think of the other things you'd want to know about a bank, like what they're doing well and how that they keep your money safe, but I think that's under reliability. I don't know. What else would be, what are other aspects of banking? That they know how to do their math? That would be reliability, wouldn't it? I feel like everything falls under reliability. So, but say they asked them 10 things, like how do you rate friendliness? How do you rate cleanliness? I know that's really not important for a bank, but you get the idea, all these things. And then we're just looking at reliability only. Any other questions from the warm-up? Michelle?
Can you go for T real quick?
I'm sorry, say it louder for me.
Can you go for T-star?
So T-star is one of those, remember I told you when you do the interval, it gives you the degrees of freedom. And I said, I'm not going to teach you the formula because it's really complicated. So just pull degrees of freedom from the T interval. So I didn't put it in my calculator, so I'm going to do it really quick. But we put in 6.37, 0.6, 92, 5.91, 0.93, 86, 95, right? Yeah. So then when we do the T interval, the first one below the interval is the degrees of freedom. Well, to find T star, you have to know the degrees of freedom. So it's kind of backwards in how you would do it. Usually before I would have you find T star first and write it down and then do the interval. But since I didn't make you learn the formula to find the degrees of freedom, do the interval first, get your degrees of freedom, and then if you go into inverse T, second vars, inverse T, 95%, so we'd add one of the tails, the 2.5, so we're looking at 0.975 for our area, and then put 143 in for degrees freedom, and you get the 1.98 that Shelley put up here. Any other questions? All right, so today we're going to look at significance tests for the difference in means. Does anybody need to borrow a calculator and hasn't grabbed one? No? Okay. Looking at the smart pill idea still. I guess I'll read it again. It's the same wording from last time. So, suppose there's a new smart pill on the market that claims it will improve ACT scores if taken the day before the test. To test the validity of this claim, we set up a randomized comparative experiment. 18 students volunteer for the experiment. 10 students chosen at random are given the smart pill the day before the test. 8 students chosen at random are given a placebo the day before the test. We then record their scores. We're going to assume the distribution of ACT scores is normal. Does this provide significant evidence that the smart pill increases ACT scores? So, by the way, I hope you guys have, with confidence intervals, it'll always say construct and interpret. With significance tests, it doesn't say, like, test it at the significance level. A lot of times it'll ask you if it provides significant evidence. So that phrase right there is a clue that you actually have to go through the whole state plan to conclude part. So, state with a significance test, anybody remember? We don't have to write a sentence. We say it louder. H null, thank you, and HA. Now, we're looking at a difference. So our null is that there is no difference. We're going to assume there is no difference. So we're going to say mu1 equals mu2. Remember I said that means that sometimes you might see it, I'm going to put it up here just as a side note. You might see it written like this. Mu1 minus mu2 is 0. There is no difference. I just like to write it this way because that's how the calculator puts it. And so to me it's much simpler to think through it. But if you want to write it that way, or let's say it's a multiple choice question, you see that as H null, that is a valid way to write it. HA, so we want to see if the smart pill increases ACT scores. So do you want to make mu1 smart pill or placebo? I saw two nods, so we'll go with mu1 is the smart pill. So true average ACT score on the smart pill. I'm going to be lazy. I'm going to abbreviate smart pill as SP. I'm going to put that right below the word smart pills. SP. True average smart pill ACT score. I didn't put much space between SP for smart pill and ACT, and now it looks like SPACT score. Sorry. I need to learn to put finger spaces, when they're teaching you the right sentence. Which means mu2, Maddie gave me a glare. mu2 is the true average placebo ACT score. So for the alternative, is mu1 going to be greater than, less than, not equal to? Greater than. What else do we put in our state? Louder.
Alpha.
Thanks. And what is alpha? 0.05, because it doesn't state otherwise. This is really bugging me that it's crooked. My paper has to be crooked so it looks straight up there. And it didn't mess with my camera. At least I didn't think it did. Anywho, what's the one other thing now? Well, yes, but it's not mu. X bar 1 minus X bar 2. Which means we have to find the average score for the smart pills and the average score for the placebos. Which, there's two ways you can do that. You might still have this data in your list because we worked with it on Friday. So you could do 1 bar or 2 bar stats and get the mean and the standard deviation. Or if you remember, well actually, when we did the interval, it would give us the mean and the standard deviation. I don't know if the t-test does. I can't remember off the top of my head. I don't have my data in my list. Oh, I do have my data in there. Look at that. All right, so we're going to find our mean and our standard deviation. You guys remember how to do that? Using 1 bar stats or 2 bar stats. Cheyenne's nodding. She remembers. Anybody else? Okay, so we're going to go to stat, go over to calc. 1 bar stats, it'll only look at one list at a time. If I do 2 bar stats, it'll do both at the same time. So list 1 is my smart pill, list 2 is my placebo, and then never mind, it won't do it for me. We have to do 1 bar stats. Because they're not the same length, it won't do it for me. Alright, so smart pill, we have an average of 23.2 and a standard deviation of 3.52. So I'm just going to put that up over here. Yes. Yeah. Mm-hmm. 23.2 and standard deviation 3.52. And then for list 2, 22.125, and let's go with 3.76. And then we can find X bar 1, which is the smart pill, so 23.2 minus X bar 2, 22.125. Any questions before I move to plan? No. All right, so X bar 1 minus X bar 2 is 1.075. Great, so plan, we have to check our conditions, random, normal, independent. And what do you guys think the calculator function is going to be called this time? Two sample t-test.
So doesn't it say assume distributions?
Yes, so when we check normal, I'm just going to quote normal because it does tell us to assume ACT distribution is normal. Random says randomized, and chosen at random, chosen at random. Independent. You guys are so quiet. You're making me feel old, and I'm really not that old, okay, Maddie? Yeah. So, I mean, it's 10 different people and 8 different people, so Zach's ACT score has no effect on Hannah's ACT score, right? Unless Zach's feeding her answers or Hannah's feeding him answers. So, but we'll go with smart pill scores don't affect placebo scores don't affect. Is that right, Nate?
Yeah.
Thanks, Nate.
Sorry, I can't see what you wrote yet.
Affect.
Yes.
I know you didn't watch the video from Friday because I was writing affect or effect or one of them, and I said it's a good thing Nate's not here because I don't care which one it is today. And I know if you had watched the video, you would have said, hey.
Yeah.
I'm pretty sure I picked the right one on Friday, but I don't remember.
I'll check these.
Okay. Any questions? Thanks, Maddie. All right, so on the do, we have to draw our picture.
Whoa.
Okay.
I love this. We're running out of space again.
You're running out of space?
No, I'm joking.
Okay. How do you know we're gonna take that much space? Okay, sorry. All right, so I do feel like I'm gonna run out of space for conclude. Maybe, just maybe, we'll do the paraphrase conclusion for this one. You guys never thought you'd get that excited for a paraphrase, did you? Yes. Yes. All right. So, normal. What's going to go at the center? The null. And what is the null?
0.
0. There is no difference.
Oh.
All right, and then you guys were, what was the other thing you were saying? Somebody was a number for the center. Okay, we'll move on. All right, so standard deviation.
Is it the big one?
It is that big thing. Just as a reminder, standard deviation when you're subtracting means, can you still see me or am I too high? We're going to take the square root of the standard deviation of the first sample squared divided by sample size plus standard deviation of the second sample squared divided by sample size and square root it. We already wrote them down, so I'm gonna, you guys okay if I cover some of this with my calculator? All right, so we have 3.52 squared, and that had a sample size of 10, so I'm going to divide by 10. And then I'm going to take 3.76, square it, and divide by 8. And then I'm going to add those together. And then I'm going to square root that. So I get 1.73. Hit my thumb. Anybody remember what else we need to put in the do part? Sorry, I'm looking out there. Sorry, Maddie, I'm getting pick on you. I'm looking out there. I see people thinking, and Maddie's going. Sorry, Maddie. Cheyenne. Yes, we have to put the general formula for the test statistic, which is what?
Oh my God, look at this.
And then you have to give the actual one, which is not fun. Is it going to end up being T or Z? T. And our statistic is x bar 1 minus x bar 2. The parameter is mu1 minus mu2. Standard deviation is that one. I guess I could have just put it down here. But, oh well. Like I've said before, it's not going to kill you to write it twice. Might actually get it more ingrained in your brain. So I'm going to label one standard deviation above and below the mean. Because, well, that's not hard. Because it's positive 1.73 and negative 1.73. What is our statistic? We put it up in our state. Yeah. 1.075, and so that's like, I don't know, here-ish we'll estimate 1.075, and then we think mu1 is greater than mu2, so we're going to shade everything to the right. And then we're going to use calculator to tell us T and our P value. You guys good if I cover it up with my calculator? Say it louder, Molly. This one? 1.075, sorry. I know I didn't write it small. Alright, so stat, go over to tests. We want 2 sample t-tests, so that's number 4. And then again, just like with all the other T stuff, you can either put in the statistics, or since we put lists in there, we're going to tell it to pull the data. I have my stuff in list 1, list 2, leave the frequencies at 1. And then we want mu1 to be greater than mu2. So mine already has the correct one highlighted, so I'm going to leave it alone. Pooled. Just leave that at no, we don't use pooled. And if you have a newer one, it'll ask you to calculate or draw. Do you guys care? Draw? We'll make sure I drew correctly. Sorry. I forgot. That's something I have in my y equals. That's just, I was graphing polynomials, and I wanted to make sure I graphed it correctly. Why is it going so slow? When you have other things in your like y equals or your stat plot, it slows it down. Alright, trying to change the brightness, sorry. So my picture looks pretty good compared to the picture the calculator gave me. Our t is 0.6201, so I'm going to put equal to 0.6201. And then our p value, 0.2724. And I definitely didn't leave myself enough room, so we will do a paraphrase. Any questions before we paraphrase the conclusion?
We don't have to write
That is a good question. I know when you draw, it doesn't give you degrees of freedom. Let's see. Then you probably should put it, yes. So degrees of freedom is 14. Truncate. Alright, and then conclude. So we're going to paraphrase. Is P greater than or less than alpha? Greater than. So our P value is greater than and or equal to alpha. Which means, do we have weak or strong evidence? And that tells us to reject or fail to reject. Weak evidence. I'm going to say against H null here, sorry. H null. Fail to reject H null. So can we or cannot, sorry. Can we or can we not accept that the smart pill increases their scores? Cannot. And again, I'm going to abbreviate. Smart pill increases ACT scores. And then just some reminder information, because we are getting close to the AP exam. Is this observational study or an experiment? Experiment. Tells us in the paragraph. Up here, we set up a randomized comparative experiment. So, could we make claims about cause and effect? Yes, experiments allow us to make claims about cause and effect. What is the scope of inference? Meaning, who could we generalize our results to? Students. There's a key word up here that kind of limits how far we can generalize. 18 student volunteers. That, remember, anytime somebody volunteers, voluntary response, it makes an effect on our results. So we could only generalize this to students who are similar to the volunteers. Questions? No? All right, we're going to look at another smart pill example. Mr. Sam, who by the way was my AP statistics teacher, believes taking a smart pill minutes before a test will improve scores. He takes an SRS of 10 North Medford students and uses them as part of an experiment. Each selected student will be part of the experiment for 2 tests. Before one of the tests, Mr. Sam will give them a smart pill. Before the other test, he will give them a placebo. He will randomize the order with which the treatments are given using a table of random digits. We're going to assume test scores follow a normal distribution, and below we have the test scores. So what's different about this set of data with smart pills and placebos compared to the previous one?
It's the same one.
It's the same people. So the same student is doing both the placebo and the smart pill. So what can we do? I'm glad you read my mind, because I was trying to think of how to phrase a question without giving away the answer. So I'm really glad you could read my mind, Jillian. Thank you. Will you say it louder, though, so everybody hears you? Yeah, we're going to subtract, make just a list with all the differences so that we don't have to enter 2 lists. Sorry, Anna.
Wait, what is that for?
This type of...
Is that for inside?
Anybody remember what it's called? Matched pairs. Because you're using the same kid for both treatments. So this is matched pairs. Might want to make a little note. Matched pairs. I didn't leave much room to write the differences, but I'm going to write really small, Zach, and put them in there. I guess before I do my differences, though, we should talk about whether we want mu1 to be placebo or smart pill and what our null and our alternatives are. I was going to make my differences here, but we need to decide what the alternative is before we actually do our subtraction. So H null, that's going to be mu1 equals mu2. Now, Mr. Sam believes taking the smart pill is going to improve test scores. So why don't we do the same as the previous one? Mu1's greater than mu2, and mu1 is the smart pill score, mu2 is placebo. Aw, man, I wrote the word smart pill. I wanted to abbreviate again. But that's okay. I'll survive. So when we do the difference, we're going to want to do smart pill minus placebo. So it's going to be top minus bottom, which is kind of weird. We kind of think top minus bottom, but we're going to do bottom minus top. So smart pill minus placebo. So 91 minus 89, that's 2. That's 9, that's -3, -2, 10, 6, 0, 5, 4, 12, right? 91 minus 79, 81, yeah, 12. What's our alpha level? Now, don't be too mad at me. Technically, because we're going to look at one list only, we can simplify our null and alternative. We're looking at a difference. So you may also see it with mu d for difference equals 0. Which is exactly what mu1 minus mu2 is. That's a D. It's a really bad capital D because it kind of looks like a 0. But it's mu D, meaning the average difference is 0. There is no difference. That's what it means. And then here, because we think smart pill minus placebo is going to improve scores, we would say mu D is greater than 0. Same idea. Our smart pill scores are greater than our placebo scores. So when we subtract them, we're going to get a positive number, right? And just so you guys know, mu D would be our true average difference in test scores. And I'm going to put SP minus P so we know that's how we did the difference. What else do we need to put? Well, we already subtracted them, so we just need X bar and our standard deviation because we're going to focus on one list. Has anybody put them in there yet? Did you get it, Maddie? I mean, I guess I'm going to need it in here anyways to do my test, so I guess I can type 2, 9, -3, -2, 10, 6, 0, 5, 4, 12. List 1. So our average is 4.3, standard deviation of 5.1. I'm going to switch back to red. Questions before we plan? All right, so random, he chose an SRS. So I'm just going to put quotes around SRS. Normal. It tells us follow a normal distribution, so I'm going to quote normal. Now here, independent, we have to go back to the 1/10 condition or the 10% condition. So 10 is our sample size. We're going to check n is less than or equal to 1/10 of n. 10 is the sample size, and we're looking at all North students. It doesn't say his specifically. And if we multiply 10 by 10, we get 100, and there are definitely more than 100 students here at North. Calculator function. This one's tricky. There technically are two calculator functions. If you made both lists in there, you could do it like we did up above and do a 2-sample t-test. But when we find the difference and make one list, we don't have 2 samples. So if we try to do a 2-sample t-test, it wouldn't work. So it technically goes back to just t-test because we're working with 1 sample only. And I'm going to put 1 sample in parentheses, just so you remember. We took 2 samples, found the difference, so we're working with 1 sample only. So in the calculator, it's just called t-test. Questions before I do the do? All right, so on the do, remember we have to draw our picture. Man, I'm running out of space again. What's at the center? Standard deviation. Almost. Remember with sampling distributions, you have to take the standard deviation and divide by the square root of your sample size. So we're going to take 5.1, sorry. Touched it and it slid down, and we're going to divide by the square root of the sample size, which is 10, which I don't know what that is off the top of my head. Square root of 10, 5.1 divided by that guy, 1.6. My right side of my curve is not very well done. So that's 1.61, and that's negative 1.61. Stop sliding. Now, for the sake of time, I'm not going to write the general formula because I'm running out of class time, so I'm not going to do this word part. I'm just going to go straight to the actual one. Noah. Shh. With this one, we're only looking at 1 sample, so it's just going to be x bar minus mu divided by s sub x over the square root of n. And then we're going to find our p-value and all that from, oh, I almost forgot. We have to shade our curve. Our statistic is 4.3, so 1.6, this would be like 3.2122. And that'd be like 4.83. If I did my mental math correct. So 4.3 is going to be in here somewhere. And we're shading to the right. Sorry. So we're going to go in. Can I cover up my picture? We're going to go in, stat, tests, Number 2, t-test. Yeah, he falls asleep all the time. But to see you asleep was like, thanks, Zach. All right. So you can use data because we have our list. We're going to set the null to 0 because we think there is no difference. And then we think that it's greater than the null. So mine is already defaulted to that one. And then I'm going to draw, just make sure I drew my I forgot to clear out that line, so it's going to be slow. So pretty good. My tail in my picture looks a little bigger, but for the most part, oops, too far off. For the most part, it looks correct. It just looks bigger because I drew it by hand. So our T is 2.67 when I round, and P 0.0129. Reject or fail to reject? H null. Reject. And we would conclude here that the smart pill works. Experiment or observational study. So cause and effect. And who could we generalize this to? Cheyenne? North Medford High School students. Can I flip? Oh, it's just to fill in the blanks, Anna. All right. You have data from interviews with a random sample of students who failed to graduate from a particular college in 7 years, and also a random sample of students who entered at the same time and did graduate. You will use these data to compare the percents of students from rural backgrounds among dropouts and graduates. What kind of significance test is that? First of all, is it Z or T?
Z.
Why? It's proportions, percents. So we're working with a Z test. Are we looking at one proportion or two proportions? Two, because we're comparing dropouts and graduates. How seriously do people view speeding in comparison with other annoying behaviors? A large random sample of adults were asked to rate a number of behaviors on a scale of 1, no problem at all, to 5, very severe. Do speeding drivers get a higher average rating than noisy neighbors? T-test. It's a mean, so it's a T-test. Average. Are we comparing somebody's average for speeding with their average and noisy neighbors, or is it like Haley's average for speeding and my average and noisy neighbors? Are we comparing like this or like me to me? Me to me, which means that it's just a t-test because we're looking at matched pairs. Two sample t-test procedures are more robust than one sample t procedures. This means that large sample sizes for two sample t procedures are less important than large sample sizes for one sample t procedures. Equal sample sizes are preferred, but it's not necessary. And before you leave,